In this video, we'll review section 3. There's two parts here. We're going to start with a little function notation when we are given an equation, and then we are going to answer all these questions based off of this graph. Sorry, my middle line got a little messy, but I have the red to dash off my y and my x-axis. So again, you may want to pause, do those two, and then make sure you pause, see the graph, see if you can answer all these questions. Okay, the top here, we're going to evaluate. This is where these annoying math words, evaluate, you gotta know what the notation is telling you to do. So you are given this function g of x, evaluate g of 3. We are given an x value of 3. We have to understand this is asking what is the y that goes with it. But how are we gonna do that? We plug it in. There's no multiplication here, that's just notation. It's telling me to plug in the 3 for x, so I will do that on the other side as well. And now I'm just going through the doing PEMDAS, going through the arithmetic. Careful, everybody, it's not 2 times 3 is 6, and then 6 squared is 36. You gotta do that exponent first. 3 squared, 3 times 3 is 9. That's still attached by 2, and everything else is still here. And now I've got the multiplication that I can do here and here. 2 times 9 is 18, minus 5 times 3 is negative 15, plus 7 comes down. And I just should have given myself a tiny bit more space. I'll finish up here. Still have my g of 3, that notation on the left side, but now on the right side, 18 minus 15 is 3, 3 plus 7 is 10. That's my answer. And remember, that's kind of the importance of the notation. G told me to go to the g function, whereas down here we're looking at f, so we'll look at function f. That's part of the notation. And the second part, again, no work here. That's just the notation. So at the end, we know in function g, when x equals 3, the y equals 10. One more like that down here, g of negative 2, same idea. Just be careful as you're plugging in. The negative is attached to the number. So when I square this, it's not 2 times 2 is 4 and the negative sign is hanging out. It's negative 2 times negative 2 is positive 4. There's the exponent. Now I see multiplication. 2 times 4 is 8. Minus 5 times minus 2 is positive 10. And we still have the plus 7. So now I can finish. Again, I just should have left myself just a tiny bit more room. So now the left side still have my g of negative 2. Right side, 8 plus 10 is 18 plus 7 equals 25. Now we have the graph. And now down here with the graph, I mean, we've got 8 full questions that we're answering here. But this is the key. As long as you understand what's going on here, these questions are pretty quick. Here you understand what needs to be done, but you actually have to do the arithmetic. And you know, little goofs happen, people goof up order of operations, just make little mistakes. But here, as long as you understand, similar to up here, this is the x, find the y. This is the x, find the y. So go to the graph. The x is negative 3, 1, 2, 3 to the left. I'm looking for where the graph is that goes with that x. So I'm looking straight up and down. There it is. That's the point that goes with this x coordinate. What is the y that it lines up with? It lines up with a y of negative 1. Same idea with the next one. And this is where I'm not trying to make this a speed contest, but just to realize if you know what you're looking for, the graph problems go pretty quickly. F of negative 1, what is the y that goes with x is negative 1? There's x is negative 1. looking for the graph that goes with that x. Here it is. And that point up here, that lines up with this y, so that's 1, 2, 3 units up. That gives me a y of positive 3. Next, f of 1. Well, here is x is 1, and the point that goes with it is right here. It is on the axis. What is its y value? We didn't go up or down off of that axis, so our y is simply 0. Number 4, the reversal. And in numbers 1, 2, 3, that was all notation. Just like up here, what is the notation asking us to do? Here, some people see it a little differently. It's asking me to plug in x is 3. Here, it's asking me to plug in x is negative 3. But how do you plug it in when you don't have a function? When you don't have an equation? That's why you need to understand the context that it's an x and it's asking for y. But that says a lot just through the notation. There is no way to reverse it with the notation. We have to be very clear for what value of x is y equal to 3. And sometimes they'd even have it is f of x equal to 3. Remember, the f of x is serving the place of y. So there's no shortcut to ask that. We have to ask that full statement, but it's the reversal. Here we were given the x, find the point, get the y. Now we're given the y value. Y is 3 is up here. Look for the point that goes with that y. We'd see it right here. And the x value would be negative 1, right? I'd have this x value 1 unit to the left. X is negative 1. All right, so these were point questions. Now, number 5, we're being asked for the domain. The domain, we're looking for the x's. What are all of the inputs that we use? What are the x's that we use? So I go to my graph. Well, my first x, so to speak, my leftmost x is right here at positive 4. My rightmost x I see is right here, which comes up to the x-axis at a value of positive 2. This was filled in, so it's still filled in here. This was open, it's still open here. And we're using every x value in between. Some people look at this, it's like you're smushing the graph up and down onto the x-axis here, up onto the x-axis here, and seeing what you cover. Just make sure if you think of it that way, the graph itself doesn't smush. Some people look at it as I push this down, it's gonna bulge out. That's missing the idea. It's just literally looking for the ups and downs of where you start to where you finish. And now that I have that highlighted, I'm starting here, 1, 2, 3, 4 units to the left of 0. I'm starting at negative 4. And I'm finishing here, 2 units to the right of the origin. So that's positive 2. This point over here was filled in, so the negative 4 will get the bracket. This point over here was open, so the 2 will get a parenthesis. My range, now I'm just looking for the y's. Same idea. But this is where we've noted some people goof. They see this is a starting point, this is a finishing point. So here and here were important x values, but then they just try and say, okay, well, this is the first y and this is the last y. That's missing the idea entirely. Just as this for the domain, we're looking for left to right. Now for range, we're looking on the y's, we're looking for bottom to top. That's what we're trying to cover. And now the bottom, well, I can kind of see 2 points lining up with my bottom. So they both kind of match up here. But the fact that this one was filled in will keep it filled in. And then my highest point, well, that's clearly right here. And in that same way, once I identified my left and right, I could see that everything in between was being used. Now that I have my bottom and top, same thing. Squish this left or right onto the y-axis, and we'd see all of these y's are being used. Now my orientation, I got to go from bottom to top. So I'm starting 2 units below the origin. That would be -2. And I'm finishing up here 3 units above the origin. That would be a +3. Both filled in, both get brackets. Last but not least, our intercepts. My x-intercepts, where I touch or cross the x-axis, my y-intercept, where I touch or cross the y. But just remember, these are points. So when I look at x-intercepts, it's very easy, hopefully, to just go, oh, touch across the x-axis happens here and happens here. I'm getting 2 x-intercepts, but this is where people make mistakes. They just write x equals here, that's -2. 2 units left. Here, that's +1. And there's a few things wrong with that. This is misleading in a lot of different ways, but the biggest thing, it's that these are points. Points have an x and a y. You're just giving me the x. So the better way to answer that is to look at this point. The x is -2, the y is 0. This point, the x is +1, and the y is 0. And there shouldn't be any ambiguity. Over here, we had brackets, parentheses, concerns, because both of these were intervals. That's not an XY pair. That's an interval, X to X. That's an interval, Y to Y. But the context, you come over here, that doesn't make any sense to say this is an interval. The idea of an intercept is just a point. So I see an XY pair, that's this point. I see an XY pair, that's this point. And same thing for the Y. I look for the y-intercept. Where do I cross the y-axis? And that happens right here. That's 2 units above the origin. So yes, that is y equals 2. But again, I need an xy pair. X always comes first. This is where some people goof. They just put what they see as the important value first, and they write 2, 0. That would be 2, 0. This is 0, 2.